On a stormy night, electricity looked like the hunger of the sky. A single flash could split a tree, set a roof on fire, or leave a field smoking in silence. For most of human history, that was what electricity meant. Not comfort, not progress, but fear. It arrived without warning, struck with impossible speed, and vanished before anyone could understand it. And yet, by the 19th century, something even stranger began to happen. In dark workshops and crowded lecture halls, men in waistcoats made sparks leap from metal to metal. Audiences gasped as blue light cracked through the air. Some laughed, some stepped back. Some were certain this new force was dangerous, unnatural, perhaps never meant to be touched at all. Then came an even more unbelievable moment. In the early 1880s, parts of New York began to glow after sunset with a steady electric light. No flame, no smoke, no trembling candlelight, just rooms, streets, and windows lit by something invisible, something that had once lived only in lightning storms and laboratory tricks. But this transformation did not happen smoothly. Electricity was expensive. Wires failed. Systems broke. People were shocked, frightened, and often unconvinced. Inventors fought over how this new power should work. Cities argued over whether it was safe, and ordinary people had to decide whether they were willing to trust a force they could neither see nor fully understand. Tonight, we begin that story. How humanity took one of nature's most violent mysteries and turned it into the hidden engine of the modern world. Before we go further, welcome. If you enjoy calm, cinematic stories about the inventions and ideas that shaped the modern world, you are in the right place. Tonight, we are stepping back into a time when darkness still ruled the streets. Distance slowed every message, and power had to be created exactly where it was used. Because to understand how extraordinary electricity truly was, we first have to see the world that existed before it. So let us go back, to the age before switches, before power grids, and before light answered at a touch. Before electricity, night still set the rules. When the sun went down, most of the world slowed with it. In a small home, one candle might be saved for the table, while the rest of the room disappeared into shadow. A child reading after dark had to lean close to the flame. A seamstress could keep working, but with smoke in the air, tired eyes, and the constant risk that one spark could start a fire. Outside, cities dimmed rather than lit up. In many streets, lamplighters walked from post to post with long poles, igniting gas lamps by hand. The glow was real, but limited. Leave the main road, and darkness returned almost at once. Late travel was slower, less safe, and often avoided unless necessary. Power had the same problem. It was local, heavy, and hard to manage. A 19th century factory ran on shafts, belts, steam, and noise. One central engine drove the whole building. If a belt snapped, work stopped. If a machine jammed, the disruption spread. If a worker was caught in the mechanism, the system did not care. Before electricity, power was not something that flowed quietly into a wall. It had to be generated on the spot, with fuel, motion, and constant mechanical strain. Even cold had to be harvested. Before electric refrigeration, cities bought winter itself. Huge blocks of ice were cut from frozen lakes, packed in sawdust, and shipped to warmer places. That is one of the strangest facts of the pre-electric world. Before people could manufacture cold, they literally mined it from winter. Communication was just as slow. Heat came from flame. Motion came from muscle, animals, water, wind, or steam. Messages moved only as fast as a person, horse, train, or ship could carry them. Nearly every part of daily life depended on something visible, physical, and nearby. This world was not primitive. It was skilled, inventive, and highly organized. But it had limits that people felt every day. Night ended work. Distance delayed decisions. Factories were rigid. Homes were dim. Cities were restricted by flame, fuel, and mechanics. People did not need a new scientific wonder. They needed better light, cleaner power, safer streets, and more control over time itself. That was the opening electricity had to fill, if it could ever become more than a spectacle. By the 18th century, electricity could already impress a room. In lecture halls, experimenters made sparks jump from metal rods. In one famous demonstration, a line of people stood hand in hand, and when the charge was released, the whole chain jerked at once. The audience laughed, shouted, stepped back. Electricity was no longer just a curiosity in the sky. It had become a spectacle on the ground. But spectacle is not the same as usefulness. A spark could amaze a crowd, yet still fail to light a street. A jolt could travel through 20 people, yet still fail to turn a wheel in a workshop. That was the real problem. Electricity appeared powerful, but only in bursts. Sudden, theatrical, and gone almost immediately. The Leyden jar seemed at first like the answer. It could store electric charge for a short time and release it on command. To people of the time, that felt almost magical. For the first time, electricity could be captured. But a jar could only hold a tiny amount. It was enough to shock a guest at a salon, not enough to power a home, a factory, or a city. And the more electricity moved from salons into public life, the more fear moved with it. People did not just see wonder, they saw risk. Sparks could ignite fumes, wires could fail, shocks could injure. Even later, when electric systems began entering cities, many people preferred gaslight for one simple reason. It was dangerous, but familiar. Electricity was different. You could not see it moving. You only knew it was there when something flashed, burned, or went wrong. There was also the problem of cost. The old world already had systems. Coal, gas, steam, horses, mills. They were dirty and inefficient, but they worked, and entire cities were built around them. Electricity would have to do more than astonish. It would have to outperform what already existed, and do so cheaply enough that governments, companies, and ordinary households would trust it. That meant solving three hard questions at once. How do you generate electricity steadily? How do you control it safely? And how do you send it far enough to matter? Until those questions were answered, electricity would remain what it had mostly been so far: a thrilling experiment, a fashionable demonstration, a force that made people jump, but not yet a force that could build the modern world. The breakthrough would come only when electricity stopped behaving like a trick and started behaving like a system. And that began with a series of strange early attempts: jars, frogs, batteries, and one argument that changed everything. The first real steps toward useful electricity came from a series of odd, almost theatrical moments. One of them happened in Bologna in the 1780s. Luigi Galvani was working with frog legs when he noticed that metal touching exposed nerves made the dead muscles twitch. To the people watching, it must have looked unsettling, as if electricity could briefly imitate life itself. Galvani believed the force came from the animal. Alessandro Volta disagreed. He argued that the effect came not from the frog, but from the contact between different metals. That disagreement turned out to be more valuable than agreement. In trying to prove his point, Volta built something far more important than a better experiment. In 1800, he created the voltaic pile, stacked discs of zinc and copper separated by cloth soaked in salt water. It looked simple. But for the first time, electricity was not just a spark or a stored shock. It was a steady current. That changed everything. A spark is a spectacle. A current is a tool. Now researchers could run experiments for longer than a single instant. They could repeat results, compare materials, and begin treating electricity as something measurable. Soon, scientists discovered that current could split water into hydrogen and oxygen, a startling sign that electricity was not just producing light or pain, but changing matter itself. But the early batteries had obvious limits. They were weak, they leaked, they corroded, and they were expensive. A pile of metal discs might power an experiment on a table, but it could not light a neighborhood or run a factory. Electricity had taken one major step forward, but it was still trapped in the world of small-scale science. And outside the laboratory, doubt remained. Why should cities replace gaslight with a system that was still unreliable? Why should businesses invest in wires, metals, and unfamiliar machines when steam already drove industry? Even when electricity worked, it often looked fragile and costly. It had promise, but not yet scale. Still, something fundamental had changed. Volta had shown that electricity could be produced on demand. Researchers had shown that it could be studied, repeated, and directed. The age of parlor shocks and party tricks was giving way to something more serious. But batteries would never be enough to power the modern world. The next breakthrough would have to come from somewhere bigger, not from chemistry alone, but from motion, magnetism, and machines. And when that connection was finally understood, electricity would stop being a laboratory achievement and start becoming an industry. The breakthrough came when electricity stopped being stored and started being generated. In 1831, in a London laboratory, Michael Faraday wrapped wire around an iron ring and connected it to a simple instrument that could detect current. When he switched the circuit on, the needle jumped. When he switched it off, it jumped again. Between those moments, nothing happened. That tiny twitch changed the future. Faraday had shown that electricity could be created by motion and magnetism. A battery was no longer the only source. If motion could make current, then steam engines, water wheels, and turbines could be turned into electrical machines. Electricity no longer belonged only to the table, the jar, or the lecture hall. It could scale. From that idea came the dynamo and the generator. Now coal, steam, and falling water could be turned into current again and again, as long as the machine kept moving. But generation alone was not enough. Electricity still needed one use powerful enough to force it into daily life. That use was light. In September 1882, at Pearl Street in Lower Manhattan, one of the first central power stations began sending electricity into nearby buildings. A neighborhood that had lived by flame suddenly lit up through hidden wires. No soot, no gas hiss, no open fire, just steady light at the push of a switch. That was the moment electricity stopped looking like a scientific marvel and started looking like a service. But the new system arrived with conflict. It was expensive. It required copper, maintenance, engineers, and public faith. Wires failed, insulation burned, accidents fed panic. Gas companies fought to protect their business. Newspapers amplified every shock and fire. City officials had to decide whether this new power was progress or a public hazard. Then came the sharper battle. Direct current against alternating current. Direct current worked, but mostly over short distances. Alternating current could travel much farther and be transformed more efficiently. Technically, that made it better for a growing world. Publicly, it made it terrifying. The campaign against alternating current was vicious. Animals were publicly electrocuted to frighten crowds. Even the electric chair became part of the propaganda war. One of the strangest facts in the history of technology is that a system that would power the modern world was sold to the public partly through spectacles of death. In the end, fear did not win. Proof did. In 1893, The Chicago World's Fair blazed with electric light on a scale most visitors had never seen. What had seemed dangerous now looked magnificent. 2 years later, power from Niagara Falls began traveling outward to distant cities and factories. That was the real breakthrough. Electricity could now be generated at scale, sent across distance, and trusted enough to build a world around it. And once that happened, it stopped being an invention. It became infrastructure. Once electricity became reliable, it did more than brighten the old world. It rewired it. Night stopped being a hard limit. Homes stayed lit after sunset. Factories no longer had to depend on one central steam engine and a forest of belts. Streets became safer. Hospitals worked with steadier light. Elevators let cities rise higher. Refrigeration changed food. Telephones, radios, subways, office machines, and eventually computers all depended on the same thing: dependable electrical power. That is why electricity became more than an invention. It became the platform beneath modern life. And some of its biggest victories were quiet. A child could read without smoke in the eyes. A surgeon could see more clearly. A shop could stay open later. A family could keep food cold in summer. A city could keep moving after dark. But this new power came with a price: dependence. The more the modern world relied on electricity, the more exposed it became when the power failed. A blackout could erase the comforts people had come to treat as normal: light, signals, lifts, refrigeration, communication. In a single moment, a modern city could remember how much of its life now rested on something invisible. That may be the clearest proof of what electricity changed. Humanity took a force once feared in storms, argued over in newspapers, and distrusted in city streets, and turned it into the background condition of everyday life. Today, a switch is touched and a room answers. A train moves. A phone charges. A hospital hums. A city glows. That is how electricity stopped being a mystery and became ordinary. And that is how humanity captured invisible power. And that is where we will leave the story tonight. What began as fear in the sky became the quiet foundation of the modern world. A force once seen only in storms now lights our homes, moves our cities, carries our voices, and powers almost every part of daily life. If you enjoyed this journey, subscribe to the channel. There are many more stories like this ahead, about the inventions, discoveries, and turning points that shaped the world we live in. Thank you for watching, and I will see you in the next story.